You can't hear anything because I'm not saying anything. I'm trying to get everybody in right now. So you heard my explanation. What the heck? Okay, so far I see I have 6 people, and I know who, oh no, 7, and I know who 7 of them are. No, I see 6, but I only know 3 names. Because whoever else is here is not speaking. Go get a snack or some type of drink or something. We're going to be here a while. We're probably going to start in 3 or 4 minutes. Just trying to send out the link, make sure everybody gets it. And we're going from there. And we're, ooh, not cute. What is happening? No, 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 no. Okay, just 2 more minutes. Oh boy, it's hot. Okay, so in the past, these have lasted somewhere between like 3 and 4 hours. We'll pretty much go as quickly as you need. You can leave comments. I have seen comments from Caitlin, Kailash, Shakira, and Destiny so far. So you can send comments wherever you're leaving those comments because I'm seeing them. And then you can also text me on Remind. I do have Remind open. I'm like working on 2 computers here. And I'm trying to pull this up on the second computer to see what's happening. But I'm not getting it. But obviously you guys are here, so it's working to some extent. Okay. Just a question. This is not mirror image, right? You guys can see these words as they're supposed to be written. Is that a yes? It's good. Okay. Everyone has a copy of June 2015? Because that's what we're working on, right? Yeah, June 2015. Okay. Perfect. You definitely need reference tables. Okay. Just get situated here. Okay, I see Saray, Jared, and Aaliyah finally figured out how to do this. Why a crying face? I don't like the crying face. Okay. Getting ready. Goodness gracious. There we go. Smiles. I keep telling everybody I'm sending you guys to the Super Bowl because that's really what it feels like. We've been training for this for the whole year. You guys are ready. This is just our last minute cram session. Okie dokie. Hope everybody is comfortable in sweats, pajamas. Just pulling out some magic markers, and then we're going to get going. You're not failing. And if you have a stinky attitude, I'm going to beat the snot out of you. It's not how winners talk. Oh, hi, Janelle. Every single marker I'm pulling out is blue. Okay, we're moving on. Ready? Set. Let's go. Holy crap. Okay. I'm sorry if this is junky. I'm just doing my best here. Okay. Question 1, June 2015. Compared to an electron, which particle has a charge that's equal in magnitude but opposite in sign? Okay. So we're given an electron. It's asking you what's equal in magnitude but opposite in sign. So magnitude is a fancy science word for like strength or power. Oh, it just totally went out of focus. There we go. Okay. So, like if you were, sorry, trying to get situated here. If you are 15 years old, 15 is the magnitude. If you are 6 feet tall, 6 is the magnitude. So electrons, we know the fancy word for an electron is also a beta particle. Those are found on table O. Guys, I'm going through this real slow. Like real slow. We're covering all the bases here. Table O, we got, holy schmoly. Sorry. Beta particles. 0 is the mass and -1 is the charge. The symbol is beta minus, or this like fancy ugly B minus. So we say it is 0, -1 beta, or 0, -1 electron. If you look at table O, the thing that is, what was the question? Equal in magnitude. That means that it is not a -1, but it has like the same weight as a -1. That would be the proton. That's +1 with a mass of 1 p proton. Okay, good. I'm glad that people are answering this. Perfect. All righty. Question 2. The mass of a proton. You're not seeing this. The mass of a proton is approximately equal to. This is basically like the same question. That's the thing with the Regents exam. They are going to recycle the questions over and over and over. If you look at the first like 2 to 3 questions of any Regents exam for chemistry, they are pretty much all going to be atomic theory. They're all asking you like the same crap. So yes, you guys are getting it. The proton's mass is approximately equal to 1 atomic mass unit. Protons are too small to measure in grams. So we measure them in, they used to call them AMU, which is atomic mass unit. They have since renamed it, and it's just U for unit. Awesome. You guys are great. See, that's the first 2. You only need 48 more to pass. Question 3. Which property decreases when elements in group 17 are considered in order of increasing atomic number? Bleh, that's a lot. Okay. Dissect it. Which property is going to drop when the elements in group 17 are considered in order of increasing atomic number? Okay, let's look at 17. 17 is over here. We got the halogens. Really, we can just look at like the first 3. We don't necessarily have to look at all 4 because usually you can pick up a trend at that point. So what you should know is as we go down the table, the atoms are going to get bigger. Their radius is going to increase. So that was choice 2. That's out. Atomic mass, we can see right here. First, we got 19, 35, 80, 127. Those are going up, not down. So choice 1 and 2 are out. Then melting point and electronegativity. Those I would just look up on table S, because they're there for you. So table S has them all listed. You got your categories up at the top. The only thing is that they go in order of atomic number. So it's important to make sure that you are looking at, you flip back and forth between the atomic number, 9, 17, 35, and you're looking at the correct things on table S. Something that, fun fact, fluorine is the most electronegative element. It's well, it's not number 4, but its value is 4 on the electronegativity scale, and that is going to drop. I think chlorine might be like 3.2. This is going to be lower than that, and this is lower. This is your most non-metallic nonmetal, if that makes sense. It's your least metallic, and francium is going to be your most metallic. So on two opposite ends of the table, we have most metallic, least metallic. Dying to get rid of electrons, dying to gain electrons. That's how it goes. So that's your electronegativity. You either know it or you look it up on table S. Question 4. Hi, Josh. Question 4. Here we go. Any substance composed of 2 or more elements that are chemically combined in fixed proportion. There is no way to explain this other than it's the definition of a compound. That's it. We can go through what everything else is. An isomer is stuff that has the same molecular formula, but it's built differently. So that would be something like ethanol, which looks like this. Sorry, let me do this. And then we put our H's on. Isomers is like 99% of the time talking about something organic. So we can do this, but we can also make ethanol, which is, or can we? Oh, technically no. Because this only has 4 carbons and this has 1, 2, 3, 4, 5, 6. However it works. You guys can kind of get what I'm saying here. They have the same formula. So like a real example would be like pentane. Pent, all single bonds. We throw in the hydrogens. Assume all the hydrogens are in there. We can do the same thing, but we can do like a methyl butane where we still have our 5 carbons. If you fill in the hydrogens, you have the same number. They're just, the molecules are just built differently. The way I describe this would be like a t-shirt and a pair of jeans. They're both made out of cotton. It's just that the t-shirt is lighter, smoother. It looks like a shirt. Your jeans, they're denim, but denim is made out of cotton. So this is going to be a much thicker cotton. They're both made of cotton, just built differently. So that's what an isomer is. Isotope is same number of protons, different number of neutrons. That's your carbon 12, carbon 13, carbon 14, back from earth science and carbon dating, radioactive dating, uranium, blah, blah, blah. Solution, you guys know, is a mixture 99% of the time. That's something that's aqueous, mixed in water. And then we have compound. Its definition is right here. Okay, moving on. Number 5. Another vocabulary term. Which term refers to how strongly an atom of an element attracts electrons in a chemical bond with an atom of a different element? How do you get the test? The test, you can just Google NYS, New York State Chemistry Regents, and we're looking at June 2015. Nice job, guys. This is choice 2, electronegativity. That's its definition. We're going to go through the other choices. Just we can go by process of elimination. Entropy, we know, is disorder of a system, how chaotic it is. Activation energy is the energy needed to kickstart or activate a reaction. And first ionization energy is kind of the opposite of electronegativity. It is pulling electrons off an atom, how much energy it takes to pull that electron off. So Fluorine has a super high electronegativity. It is saying, please, 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 I want to keep my electrons. Don't take them away. I'm actually looking for another one. Its first ionization energy is going to be super high. Francium, on the other hand, has a very low ionization energy because it's trying to get rid of its electron. All right. Number 6. At STP, which substance has metallic bonding? Okay. 2 of those you should eliminate right away because they don't have metals in them. It is choice 4. 1 and 3 need to be eliminated because ammonium chloride, that's NH4Cl, no metal. Iodine is an element, no metal. That's a nonmetal. Barium oxide is going to be something ionic. We have a metal and a nonmetal, and then silver is the only metal all by itself. That's the way metallic bonding works. We have a bunch of protons or nuclei of metals all organized. And then what happens is we have our sea of mobile electrons, and these electrons kind of just swim around. And that is why metals are malleable, which means they're flexible. They are shiny. They're conductive. They lose electrons because they just float around. It's really easy to pluck them off. It's a sea of mobile electrons. That's what makes metals. Yes, they're also ductile, which means you can pull them out into a wire. Can't really do that with glass. It's not kind of the way it works. Alrighty. Moving on, we're up to number 7. Ooh, this is a good one. I actually think this was on... Actually, I didn't give 212 an organic test. I think it's the other guys I gave the organic test. It may have exactly been this question. Question 7. What is the number of electrons shared between carbon atoms in a molecule of ethine? Okay. Easiest way to do this is draw it and then figure it out from there. We have ethine. Sorry, you can't see that. Eth means I have 2 carbons. So I'm going to draw 2 carbons. This ine ending means there's a triple bond between them. Each carbon needs to bond 4 times, 1 hydrogen each. If you forgot any of that, it is on tables P, where I have 2 carbons, is eth, and then down here, this is literally a molecule of ethine on the table. That's the example they give, and that's the YNE ending. How many electrons are in each bond? This carbon gave 1 electron. This carbon gave 1 electron. So there's 2 electrons per bond. I have 3 bonds. That's a total of 6 electrons, which is choice 1. Nice job. Okie doke. How is everyone feeling so far? Are we doing okay? We're a little bit less scared because that's like the most important part here. Less scared. Remember the first 30, the part A, is all multiple choice. And it is reference tables and vocab. You should not touch a calculator in the first 30 questions. If you do, like 99% chance that something is going wrong. That's what we're doing right now, the first 30. Okie dokie. We have number 8. Which atom in the ground state has a stable valence electron configuration? The whole test is not like this, but you only need 50 questions out of 85 typically to pass. It's any 50 questions. It doesn't matter which 50. They're all rated the same. So back to question 8. Which atom in the ground state has a stable valence electron configuration? Your brain should immediately take you to the noble gases. The reason we call them noble is because they do not play with the rest of the table. They are the kings and queens of the table. They have achieved their octet. They're happy. They're stable. They're not playing games. So that would be argon, choice 1. Going through them, aluminum is a metalloid. It's really a metal, but it's kind of a metalloid. It depends on who you talk to. I would tell you it's a metal, but you could argue it's a metalloid. It hits 2 sides of the staircase. So the real true metalloids that no one's going to argue is going to be boron, silicon, germanium, arsenic, antimony, tellurium, maybe polonium, depending on who you talk to. It's radioactive, so it's a little bit of a weird one. But these 1, 2, 3, 4, 5, 6 that touch the 2 sides of the staircase, absolutely metalloids. Then we have silicon is also a metalloid. Sodium over here is an alkali metal. These guys make very strong bases. Alkali, alkaline, same. That's where the word comes from. We got group 2. These guys are our normal metals, group 1 and 2. This junk in the middle is our transitions. Remember, you're going to get a reference table that looks like this for the test, like it's blank, crisp, brand new. Once you get in there, you're going to have to write your little notes all over it. Here you got your metalloids on the staircase, non-metals, halogens are group 17, noble gases are group 18. These guys down here, nobody really talks about them all that much. They're also metals. The ones on the bottom row, radioactive, man-made. These guys are all radioactive, man-made. That's all you need to know for now. So moving on. Question 9. Question 9 asks, which occurs when 2 fluorine atoms react to produce a fluorine molecule? Okay, this is an acronym. We got 2 fluorine atoms reacting to form a fluorine molecule. F and F is going to form F2. So we could even do this as a Lewis structure. Fluorine has 7 valence electrons. Don't draw it like that. You should draw it like this. 1, 2, 3, 4, 5, 6, 7. Go around so you don't accidentally double it up. This is going to become fluorine. 2, 3, 4, 5, 6. Bond. 1, 2, 3, 4, 5, 6. This is where the fluorine says, I will share 1 electron with you if you share 1 with me. Don't draw them like this. Please, for the love of God, don't draw them like this. Remember, we drew them like this, and then we said, okay, now draw it like a chemist. Make it a solid line. Solid line. Draw it like a chemist on the test. This is the acronym BARF. When you break a bond, you absorb energy. When you form a bond, you release energy. Here, we are forming bonds. We literally drew it right here. Forming bonds is a release of energy. So that is going to be choice 4. Nice job, people. Nice job. Okay, question 10. Which sample at STP has the same number of molecules as a 2-liter sample of chlorine at STP? Important thing here is that chlorine is a gas. And this is Avogadro's law. We know that if it's 2 liters of chlorine, 2 liters of helium, 2 liters of methane, 2 liters of oxygen, as long as it's a gas and it is taking up the same amount of space, they're going to have the same number of molecules, same number of particles. So that is going to be choice 2. I can't really explain it any more than it's Avogadro's law. In class, I told you 2 equals 2. 2 liters is equal to 2 liters. As long as they're both under the same conditions of temperature and pressure, STP, then they're going to be the same. Okay. Number 11, it's distracting you. It's asking you, what is the definition of an element? All atoms of uranium have the same what? mass number is not true. That is uranium. I don't even know the mass number of uranium. But table N tells you a bunch of different mass numbers for uranium. 233, 235, 238. Uranium comes in lots of different mass numbers. Number of neutrons plus protons. Hey, that's the exact same answer as mass number. They do this because there's not even enough answer choices for them to explain this nonsense. They're just both wrong. Number of neutrons plus electrons is not even a thing. They just made that up. They all have the same atomic number. Its atomic number is 92. It's on the periodic table. There we go. All right. 12. The concentration of a solution can be expressed in. Okay. This, if you didn't know it off the top of your head, you could look it up on table D. Table D tells you what all units are for. So not all units, but like 90% of the units. So we're looking for concentration. This one tells us concentration can be measured in parts per million. We could also measure it in molarity. Kelvin measures temperature. Sorry, too high. Kelvin measures temperature, so that answer choice is out. Then we have milliliters. Milli just meaning a small liter. Liters measure volume, which is not the same as concentration. Joules per kilogram. Joules is energy. Kilo is just a big gram, so that would be energy per unit of mass. That's not concentration. It's actually moles per liter is molarity. Molarity comes up again on the table. It is table T, everyone's favorite table. Mole calculation is not here. Concentration, we have two ways to calculate concentration. We can also use percent composition. But here we have molarity, which is moles per liter. That's literally what it is. So these first 12 questions, the first page of the table, we did not touch a calculator. We were really just looking at the reference tables. It's can you read the reference tables and do you know some basic chemistry definitions? It's all very basic for the first 30. And even after that, you'll see that it's a lot easier than you think it is. Okay. Question 13 gets into colligative properties. Compared to the boiling point and freezing point of water at 1 atmosphere, a 1 molar calcium chloride aqueous solution at 1 atmosphere has what? Now, this was somebody's science fair project, trying to calculate the boiling points of different things. But this goes back to, the winter time and why we put salt out on the roads. What this does, when you add anything to water and it becomes, you have now an aqueous solution. Think of a thermometer. We know that water is going to freeze. Its freezing point is 0 degrees Celsius. Its boiling point is going to be 100 degrees Celsius. Freezing point and melting point are the same thing. Boiling point and condensing point are the same thing. Nobody talks about that because it's not actually a term, but sort of. When we start dissolving stuff in water, what happens is that the freezing point goes down and the boiling point goes up. So this is it depends on how much stuff you put in and what stuff you put in. So we did this together. Calcium chloride, this dissolves. It is going to dissociate into 1 calcium and 2 chlorines, which in total is 3 parts. So it being 3 parts, it is going to expand this liquid phase a lot. If I were dissolving, say, NaCl, it would maybe look something like this. And then for calcium chloride, I'm just going to put them side by side. It would look something like this. So this is what 2 parts is going to do. This is what 3 parts is going to do. This is going to go up and this goes down. And we're just expanding the liquid phase here. So we are going to get a lower freezing point. This is going to be something less than 0. And this is going to be something greater than 100. That answer choice corresponds with, I'm trying to find it, 3 higher boiling point and a lower freezing point. Those are your colligative properties, expanding the liquid phase. That's always how I've taught it, because this nonsense, too difficult to remember. You get confused. It's kind of crazy. Just stick to the expansion of the liquid phase. If you have to draw it out, draw it out. No one is going to judge you. We're all in this together. We're all just trying to beat this test. All right. We are at 14. According to the kinetic molecular theory, which statement describes an ideal gas? Okay. This is just basic memorization. I'm sorry, it sucks. I can't do anything more than that. Gas particles are diatomic. Sometimes, not all the time. It depends on what the gas is. So, no. We should go through what the diatomics are, since we're talking about them. There are 7 of them. Diatomics. Diatomic, 2 atoms. Diatomic elements are going to be Brinkelhoff, Br2, I2, N2, Cl2, H2, Brinkel, O2, F2. Did I get all 7? Yes, I did. Those are your diatomic elements. Plite does describe an ideal gas, yes. But that has nothing to do with the kinetic molecular theory. I mean, it does, but it doesn't. When gas is under low pressure, ideal gas, high temperature, when it's under these conditions, that means it's following the kinetic molecular theory. The two go hand in hand, but they're not the same thing. So we have gas particles are diatomic, sometimes, but not always. Energy is created. No, 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 no. We are humans. We do not create energy. That is up to higher powers. We do not have that power. Moving on. There are no attractive forces between gas particles. That sounds ideal, because then I don't have to talk about intermolecular forces ever. The distance between gas particles is small compared to their size. That's confusing, but it's really just telling you that the molecules are close together, which we know for gases, they spread apart really, really, really far. Solids are squished together. So yes, Aaliyah, it is choice 3. There are no attractive forces between the gas particles. Nice job. Okay. 15. Partly my favorite question, also partly the worst question. Which physical change is endothermic? This is, if you're like a good test taker and you're able to like read and dissect a test, this is an easy question. If you are a chemistry kid, you're like, wait, I'm confused. They're all carbon dioxide. There's so many parentheses. They all look the same. Chill. It will be fine. First, we have a solid becoming a gas. Ignore the fact that they're all carbon dioxide. Doesn't matter. So if we have a solid becoming a gas, that means it's getting hotter. Energy has to be going in. You guys are rocking this already. Let me explain it for everyone else. We have in choice 2, a liquid becoming a solid. That has to get colder. The heat or the energy has to come out. Same with a gas. Gas to liquid is getting colder, and a gas to a solid is getting colder. So for you test takers, when you're getting colder, if 3 options are colder and only 1 is warmer, then it has to be the 1, not the 3. But also for the rest of you chemistry-brained people, solid to gas energy has to go in to make it hotter. And for all these others, energy is coming out and it's leaving the system and going out into the environment. Alrighty. Question 16. Which group 16 element combines with hydrogen to form a compound that has the strongest hydrogen bonding between its molecules? Alrighty. Hydrogen bonding, not a bond. Whoever named it is a butthead and I don't like them. They should have named it hydrogen forces. Do we remember all the elements that hydrogen bond? It's hydrogen, Fun. Yes. Because hydrogen bonding is so fun. That is going to be nitrogen, oxygen, and fluorine. Those are the guys that are going to hydrogen bond. You don't have to know the reason why it's oxygen, fluorine, and nitrogen. All I'm going to tell you is that it's a combination of electronegativity and atomic radius, and that it's a deeper chemistry than you need to know. But you do need to know what the elements are, not why. So there you go. Choice 1, quick and easy. Moving on. Ooh, this is my favorite question of all time. 17 hydrocarbons are composed of the elements. Dun, dun, dun. Yes, it's 1, hydrogen and carbon only. Hydrocarbon. Hydrogen and carbon. That's it. Quick and easy. 18. Which atom is bonded to the oxygen? I just gave the answer. Which atom is bonded to the carbon atom in the functional group of a ketone? Okay, we have a whole table of functional groups. That is table R. We're going to take it out because this is a morning test and got to check our work. So we're looking for the ketone, which is right here. Ketone, we see has a double bonded oxygen. That's what makes it a ketone. We know that the double bonded oxygen is somewhere in the middle of the molecule, not on the end. That's what makes it a ketone. So 18 is going to be choice 4, oxygen. Okie doke. 19 is just a memorization question. There's no other way past it. It's just definitions. So we have 2 types of organic reactions. Are addition, yes. Sublimation, no. Sublimation is the phase change of solid straight to gas. Is this blurry? Goodness gracious. Or is that just my eyeballs? 2, deposition is the opposite of sublimation. That is a gas straight to a solid. Saponification is making soap. That's organic. That's good. 3, decomp can be any reaction, organic or inorganic, does not matter. Evaporation is a phase change. Then we have esterification, making an ester, and polymerization, making a polymer. Those are all organic. That's choice 4. Why, if this were a part B question, they would not put in all these phase changes. That's a phase, sublimation, deposition, and evaporation. Those are all phase changes. That's what makes this a part A question. Had this been a part B, those would have been synthesis, fission, fusion, single replacement. Those would have been the answers in the part B. Okay, question 20. Isomers of butane and methylpropane. Here we go. We already know ISO is a prefix meaning same. Isomer, isotope. There's something that's similar about them. So what is it that's the same? We went over this just before. They're going to have the same molecular formula, but they're going to be built differently. Polymerization is the slime lab that we did. Sorry, backtracking, just saw that question. All the little carbons link together and make a giant carbon link. Oh, you guys are great. You guys are awesome. Sorry, back to 20. The same molecular formula and different properties. If they're built differently, they're going to look, feel, smell, boil differently. That's just the way it works. It has to do with where all of the hydrogens are, the carbons are. Methylpropane is just going to look like this. And it's going to have the CH3 group here. Instead of having butane I'll do here. Butane would look like this. That's the difference. This is the methylpropane because we have a methyl group on a propane. They should have called it 2-methylpropane to be really precise, but the 2 technically is not necessary. because if it's a methyl propane, it has to be on carbon too. Okay. We've done the first 20. How's everybody feeling now? Feeling all right? Okay. All right, I'll take it. You'll see this test is so repetitive. The same questions over and over and over. All righty. 21. In a redox reaction, which particles are lost and gained in equal numbers? So redox, we didn't necessarily go over in class. I did a lot of that Saturday school and after school. So I'm going to do a little bit of a run through right now. Redox stands, it's a kind of a made up word. I mean, I guess all words are made up, but it stands for two things. It is reduction and oxidation. Yes, Aaliyah, it is electrons. Way to go. Okay. In reduction, random question, what is voltaic cell? I think there is a voltaic cell on this test. Did I look at it properly? Yes. Questions 83 to 85 are a voltaic cell, as like stupid as it looks. It is. So we will go in more depth when we get there. So in reduction, we are going to be gaining electrons. In oxidation, we are going to be losing electrons. So this is just like garbage nonsense words for stuff you already know. Sodium has 1 electron. Chlorine has 7. When they bond and become sodium chloride, sodium loses the electron, gives it to sodium. It becomes Na+. Cl is going to gain that electron. It becomes Cl-. Remember, we use the brackets to hold all these electrons together. That's what oxidation and reduction is. That's the gist of it. We would say that sodium is oxidized, chlorine is reduced, and that's it. We have a cute acronym to help you remember. You could use oil rig. Yes, there are some people who use that. Oxidation is loss, reduction is gain. I prefer Leo says GER. Lose electrons, oxidation, gain electrons, reduction. It makes me think of a lion, and lions are cute. So that's where I'm at with it. We have all types of details we can get into with this, how batteries work, just different reactions that rely solely on movement of electrons. And if electrons didn't move, reactions wouldn't happen. This is what I'm going to leave it at for now. So for question 21, which I lost, here we go. 21, we are gaining and losing electrons in equal numbers. Yes, fantastic. 22, what is the oxidation state for a manganese atom? Atom is the key word here. Your brain may be saying go to the periodic table, but I'm saying review your vocabulary. If it is an atom, we know something about it. Are we kind of stuck? Because manganese has lots of different charges on the periodic table, and you're like, oh, this is kind of crazy. What do we have? We have 2, 3, 4, and 7. Okay, so test takers. Yes, it is choice 1. So here you go. An atom In an atom, the protons has to be equal to the electrons. Your positives have to be equal to your negatives. It is overall going to be neutral. That's what an atom is there for. So test takers on the periodic table, you have manganese, you have +2, +3, +4, +7. It's not a coincidence that the 3 other answer choices that are not 0 are all listed right here. That's done on purpose. It's done to confuse you. They are trying to make sure that you know that an atom, by definition, is neutral. So the overall charge should be Mn0. And for those of you who did redox with me, there you go. That's it. They do a lot to confuse you. They do it on purpose. They are trying to weed out the winners and the losers. Separate them. Alrighty. 23. Which compounds are classified as electrolytes? Electrolytes are going to be solutions that conduct electricity. If they're conducting electricity, it is because they have mobile ions. Mobile ions, you're going to have positives and negatives, and they're swimming around. And then you got some water molecules floating in there too. That's what makes charges able to swim through. You got your mobile ions. So things that are guaranteed electrolytes are acids and bases. Acids and bases are always going to be electrolytes. And then we can add in things that are both, you can't have one or the other. It has to be both. It has to be both ionic and soluble. So this is going to be ionic, a metal and a nonmetal, and soluble, you're going to learn from table F. That's it. So looking at the answer choices, we have KNO3 and H2SO4. KNO3 is something ionic. I'm going to double check on table F to make sure that that's soluble. Table F. We see NO3. Where are my nitrates? Nitrates are always soluble with no exceptions. Remember, when you get your tests, you're going to draw a circle around your inner 2 columns. The things that fall in the circle in your inner 2 columns are going to be insoluble. They don't dissolve. Because nitrate would be on the outside of that circle, that makes it soluble. So there you have it. It's choice 1. Ionic and soluble, and an acid. If you forgot that's an acid, it's on table K. Then we have KNO3, soluble, and this is methanol and alcohol. Nothing's dissociating or ionizing there. Here we have an ether and an acid, an ether and an alcohol. Okay, 24. Oh, there's a bug flying around. 24, which compound is an Arrhenius base? 2 choices you're probably going to eliminate immediately would be 1 and 2. Reason for that is that an Arrhenius base, you know, is going to have an OH on it. And then I'm going to look at these. We know that Arrhenius bases are going to be ionic, a metal bonded to a nonmetal. Your metal is calcium. Nonmetal is your hydroxide. For choice 4, this is an organic alcohol. You would look that up. It's a carbon covalent molecule. That should just tell you, hey, check if it's organic. If I look this up on table R, this is ethanol. That's an alcohol. Not the same as a base. Still has the OH group, but it's a little bit different. Definitely not an Arrhenius base, though. Okay, this is the part I was telling you guys about. They never, ever, ever use the words Bronsted-Lowry acid base. I don't know who's got a grudge against Bronsted and Lowry, but they always refer to it as one acid-base theory. Water is going to act as a base when it accepts what? So we remember another acronym because I'm full of them. BAD, Bases accept, acids donate. The question is, what are they accepting or donating? That is a proton. A proton is not a neutron. It's not an electron. OH minus is also not a proton. That would be an H plus. H plus, the reason we say it's H plus is because it is, H has one proton and it's positive. It has no electron. That's what makes it a proton. So there you go. Bases accept, protons. There's your first 25. So if you feel comfortable with the first 25, you're on the right track. You need roughly 50 to pass. So at this point, you're halfway there. You're halfway to passing. And we're 25 questions in. And I know that you guys are not just gonna pass. You're gonna do better than just passing. I know this. You guys rock the house. Okay, moving on to 26. We're given an equation. We're given an equation representing a system at equilibrium. You know this is at equilibrium because one, it's the Haber process, and we've done it 100 times. And two, you have this double-sided arrow. Your double-sided arrow means that it's equilibrium. Your reaction is going both forwards and backwards. So our reactions at equilibrium, when we are at equilibrium, we know that our concentrations are supposed to stay the same. They're supposed to be constant, and your rates are supposed to be equal. So at the same time that N2 and H2 are coming together to form NH3, NH3 is breaking apart and becoming N2 and H2. It goes forward backwards at the same time. So for this one, you have your con. Your concentrations are constant. It's part A. It's just one of those silly memorization things. Okay. 27. Vocabulary. The acidity or alkalinity of an unknown aqueous solution is indicated by its what? Yes, Aaliyah, for equilibrium, when one person gets off the bus, another person gets on. That's exactly how I described it. Perfect. And the number of people on the bus stays the same. That's your concentration staying constant. Okay, so going through the words, pH value is the answer. That's just its definition. The electronegativity, we already went over that. That's how badly it wants an electron. It pulls the electrons in a bond. Percent by mass concentration. I don't even know what that means. I think that's made up. Percent by mass concentration. My guess is that they're trying to talk about molarity, moles per liter, but moles per liter is not necessarily mass. And then you have volume concentration. It's just pH value. That's just the answer. Destiny, do you have a question? I just don't want to miss anything. Okay, it looks like no, so I'm just going to move on. Okay, question 28. Laboratory process in which the volume of a solution of known concentration is used to determine the concentration of another solution. What does acidity mean? Acidity is an adjective to describe how acidic something is. So if you put, if you have like a big beaker full of water and you put in one tiny little drop of acid, this is going to be only a little bit acidic. It's going to have low acidity. But if I have a big beaker of water and I pour an entire beaker of acid in, then this is going to have high acidity. Does that help? When it's higher or lower on the pH scale? Yes. So this would have a low pH and this would have a higher pH. but not necessarily a high pH. Because remember, your pH scale is running from 0 to 14. 7 is neutral. 1 to 7 is going to be acidic acid. It's going to have acidity. And this is your base, which some people call alkaline. I don't even know if I spelled that right. But this high acidity would be closer to this end. And your low acidity would be like here-ish. Okay. Going back to 28. We are trying to determine the concentration. Knowing the concentration of one, determine the concentration of another. That is just titration. There's really no other way to put it. Other than that's the answer. It's a part A, it's a vocab. Distillation is a lab process. We use it to separate mixtures. We are going to separate them by their boiling points. And we have like that whole boiling flask. Vapor is going to rise. It goes up into a tube that's surrounded by a tube. We should connect these. In here, you're going to have vapor. And then around here, around here, you have cold water. And when this vapor is near the cold water, it's going to condense. And then it drips out as a liquid. The thing that has the lower boiling point is going to boil first and come over. I should specify that we do this over flame 99% of the time. You can also use a hot plate. That's what distillation is. Separating by boiling points. Then we have fermentation, which is an organic reaction where we take sugar and turn it into an alcohol with carbon dioxide as a byproduct. Sorry, this thing doesn't want to focus, really. Hi. Okay. Titration was the answer. And a transmutation is a chemical it's not a chemical reaction. It's a nuclear reaction where you have one element transforming or mutating into something else. Okay. 29. Which list of nuclear emissions is arranged in order from the greatest penetrating power to the least penetrating power? This is like last day of school stuff. So we're looking at alpha, beta, and gamma radiation. Alpha and beta, you can actually, all of these you can find on table O. I'm going to run through it quick because we did it for like 10 seconds in class. We have alpha particles, which you should remember from Rutherford. You have the alpha particle. It has 2 protons and 2 neutrons. The 2 protons are this number here. The 4 in total is that number here. That's your mass number. That would be sort of like your atomic number. We also sometimes write this as helium because it has the 2 protons. Then we have our beta particles, which again, fancy name for electrons. We write them one of 2 ways. And then we have our gamma radiation, which is 0 over 0. This is just energy. It is not mass. So what happens? We have our big fat alpha particle. Sorry. We have the big fat alpha particle. We have this tiny, almost no mass electron, and then a literally 0 mass blob of energy. It's a wave. If I have a sheet of paper, a thin sheet of metal, and then I have like a big giant block of concrete or cement, the alpha particle is going to get stopped by the piece of paper because it's gigantic. It's like you punching through a wall. That's what an alpha particle is trying to do. Then we have beta that is going to be stopped by a sheet of metal because this is going to be a little bit more dense than the paper. That's beta. And then you have your gamma, which is going to be stopped by concrete. So we kind of go in order of size for that because so we're going from greatest penetrating power to least. So it is gamma, beta, alpha, which is going to be choice 4. That goes by mass. Okay. More nuclear. Question 30. Given the diagram representing a reaction, we have a neutron hitting a uranium atom. The uranium is splitting and it's becoming a strontium and a xenon. And then we have some neutrons as byproducts. Which type of change is represented? This is definitely choice 1. Fission is when we have big atoms like uranium and we disturb them. This is super, super, super delicate. You throw a neutron at it and they all start popping open, and these guys are going to hit other uranium atoms and split them. And it's literally splitting an atom. We split them into 2 smaller atoms. That's what fission is. Fusion is the opposite. Fusion is when we take hydrogen and helium and fuse them together into bigger elements. So that would be something like hydrogen and helium are going to fuse together and become lithium. That's a 1, that's a 2, that's a 3. 1 plus 2 equals 3. That's what you're going to get. It could also be 2 hydrogens that fuse together to form a helium. Then we have deposition, which we went over, is gas back to solid. And then we have evaporation, which you know is liquid to gas. So first 30, how many vocabulary words were on here? I couldn't even tell you how many. It's a lot. If you don't know the vocab, you're going to have issues. Deposition came up on this thing like 3 times. You just got to know it. Just got to know it. Okay. Here's your B1s. B1 is going to be more multiple choice. Destiny, there is a little bit of a lag just because it's a live stream. I don't know why it works that way. But yes. Okay. Looking at 31. Oh, sorry. I was talking about the B1s. So for part B1, we are talking about deposition is solid to gas. No, that's sublimation. Deposition is gas to solid. It's the opposite. Your B1s are reference table vocabulary, but also you need like a little bit more chemistry knowledge, and you're typically going to have to use a calculator. So how about we take like a 1-minute break? Everybody grab a calculator. I'm going to grab a drink because I'm getting cotton mouth talking nonstop. Yes, I will definitely show you Cooper at some point. Okay. Ready for 31? That was like a minute and 30 seconds. Okay. 31. Which electron shell contains the valence electrons of a radium atom in the ground state? That's a periodic table question. Radium in the ground state. So we need to know the symbol for radium. That is going to be Ra. If you don't know, look it up on table S. Ra is down here. The most common wrong answer is going to be 2. Because it has 2 valence electrons. It is asking you which shell are those electrons. You look at these guys, drop the 1, everything here is going to have 3. Drop the 1, everything here is going to have 4. Drop the 1, everything here is going to have 6. That's how it goes. That's your group numbers. Your periods tell you the number of rings of electrons. So this has 1 ring because it's the first period. Second ring is in the second period. Third ring, third period. Now, the reason that these transition metals are not up at the top of the table is because the first, second, and the third rings are short. They're little. They are, I mean, think of a bullseye. That's how we think of atoms, right? We have our nucleus in the middle, and these rings are getting bigger as we go out. Once you hit the fourth ring, you have enough space to add this many electrons. I mean, it gets kind of crazy. So radium is going to have 7 rings of electrons. So if you look at radium here, it says -18, -32, -18. It doesn't start with your first 2-8-8. It skips a few because it has that many rings. It doesn't fit across the box. That's how that happens. So 31 is choice 3. But this is what happens. You guys are here to get the answers wrong so you don't get them wrong tomorrow. Okay, 32. Each diagram below represents the nucleus of an atom. Okay. How do you know how many? Okay. How many different elements are represented by the diagrams? Okay. What is going to make the nuclei of these elements different? That's going to be their number of protons. This guy has 1 proton, 1 proton. Don't care how many neutrons, don't care the mass, don't care how many electrons. These guys are the same element. 1 proton means that they're both hydrogen. 2 protons, they're both helium. They have different mass numbers, but they have the same number of protons, which makes them both helium. So we have 2 different elements here, hydrogen and helium. Nice job, people. Okay. 33. Chlorine and element X. Element X is not a thing. It's like in math, they give you a variable. Element X is just any random element. They haven't named it, or they don't know what it is. Like they found it on a table and they're like, hey, what's that? They named it X because they don't know. They have similar chemical properties. So X and chlorine have similar chemical properties. The atom of element X could have an electron configuration of what? Okay. What gives elements their similar chemical properties? I'm going to tell you this first thing in the morning before I high five you. It is going to be chemistry is all about the electrons. 1010% chemistry is all about the electrons. Everything in group 1 has 1 valence electron. They all are going to react violently with water. Everything in group 17 has 7 valence electrons. They are all poison. Everything in group 18 has 8 valence electrons. They're all stable. The number of valence electrons is going to tell you how they're going to react. So everything in group 17 has 7 electrons. They are so close to filling their octet, they are going crazy. Fluorine is screaming at the top of her lungs, please, 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 give me an electron, because she's super, super close to having that octet. So everything in group 17 needs one more. They have the same goal. So for 33, this is going to be choice 4, because in choice 4, the 7 is the valence number. It's the last number. Valence means outside. The non-metals are definitely girls, because I like the non-metals the best. Just saying. They also change their names when they get married, like girls do traditionally. I mean, they don't have to, but it's an option. Okay, 34. Which group of elements contains a metalloid? Okay, remember, metalloids touch 2 sides of the staircase. Two sides of the staircase. Group 2, all the way over here. Staircase, over here. That's out. Group 8, all the way over here. Staircase is over here. No good. 16, we got tellurium. That works. And then group 18, noble gases, nowhere near the staircase. It's group 16. Choice 3. Sometimes the part B's are really scary, and sometimes you almost can't distinguish them from part A's. That was an easy one. But in order, it is a part B question though, because you need to know what a metalloid is, and then you have to be able to identify the groups on the periodic table. That's like a 2-step thinking problem. 35, which Lewis dot diagram represents a fluoride ion? So here, fluorine got her electron. She was married to somebody else, got an electron, changed her name. She is now fluoride. So, fluorine started out with her 7 valence electrons, bonded, gained an electron, which would be reduction. Now she's got 8, gained a negative, so her charge is -1. Use the brackets to hold all your electrons in. Nice job, people. Loving it. Okay, we are up to 36. 36, I think, is the first true tough question of the test. In the formula for the compound XCl4, the X could represent which element? Now, this is where you're going to uncrisscross and figure out which of these would take on a +4. If we look at the periodic table, hydrogen is out. Hydrogen only ever wants to be plus or minus 1. Magnesium only wants to be positive 2. That's that tiny little 2 right there. And zinc only ever wants to be plus 2. The only thing that could be positive 4 is going to be carbon, which is kind of the whole basis of the idea of organic chemistry. Organic chemistry, we have carbon. We know carbon bonds 4 times. A lot of the time it's oxygen, but it could very well be chlorine. Why not? 1, 2, 3, 4. There you go. Doing this without a table, Knucklehead, it's online. Pull it up in a different window. Okay, 37. The formula C2H4 can be classified as, okay. Structural is out. Structural shows you the structure, literally shows you how it's built. This is a structural formula because it has bonds. What else? These are omitting hydrogens, but they would be structural formulas if they were finished. because it shows you the structure. The molecular formula is the true formula of the thing that like you would be holding in your hand. The empirical formula is the most reduced version of your substance. So C2H4, technically, mathematically, we could reduce that to CH2. So empirical's out, leaving us with the molecular formula only. Kill the battery of your iPad. Give him a wet willy.